Okay. So finally, in this, we are discussing polysaccharides, and this is unit 13.7, and then we are going to look at some worked out examples in the next unit. So polysaccharides by definition are made up of multiple monosaccharide units. And cellulose is a polysaccharide. Here we are talking about cellulose, and cellulose is composed of beta-1,4 glycosidic bonds. So we know what beta-1,4 is. So there is your beta-1 carbon 1, beta-hydroxyl carbon 4, beta-1,4. So this is a beta-1,4 glycosidic bond connecting the glucose units in cellulose. So here the learning goal will be to describe the structural features of amylose, amylopectin, glycogen, and cellulose, and these are the polysaccharides we are discussing. So a polysaccharide is formed when monosaccharide units are joined together. Important examples that we'll be looking here are amylose, amylopectin, cellulose, and these are polymers. Polymers again are large molecules made up of small units called monomers. And in these three polymers or polysaccharides, both mean the same here, amylose, amylopectin, and cellulose, the monosaccharide unit is alpha-D glucose, or the monomer is alpha-D glucose, and this is alpha-D glucose. So alpha, OH is below the plane, D, this hydroxyl determines its D, so it's alpha-D glucose. Amylose and amylopectin, the structures amylose, a straight chain polysaccharide, amylose, 1,4 glycosidic bond, alpha 1,4 glycosiding, and amylopectin is a branched structure, 1,4 glycosidic, 1,6 glycosidic. So they both are polysaccharides. The structures of amylopectin is branched glucose chain, amylose is a straight chain polysaccharide, and both are starch, 20% starch, 250 to 4,000 alpha-D glucose molecules. So there are so many units of alpha-D glucose in amylose. Again, it is a straight chain polymer in which all these glucose units are connected to the alpha 1,4 glycosidic bond in a continuous chain. And that is the polysaccharide or polymer amylose. But all those polymers are coiled in a helix. They are straight chain, but they're coiled. So amylopectin makes up as much as 80% of starch. So amylose and amylopectin both make up starch molecules. So amylose makes up 20% of starch, amylopectin makes up 80% of starch, but amylopectin is a branched chain. There are branches coming out of those straight chains. The straight chains are connected by the 1,4 bond, and the branches 1,6 glycosidic bonds. Starches hydrolyze easily in water. Hydrolyze is break down into smaller units and give smaller saccharides called dextrins, which then hydrolyze to maltose and finally to glucose. This is the process of hydrolysis of starch. Final product, glucose. Glycogen. Now, glycogen is also a polymer or a polysaccharide of glucose that is stored in liver and muscles of animals. It is hydrolyzed in our cells at a rate that maintains the blood level of glucose and provides energy between meals, glycogen. So this is stored in liver and muscles and provides intermittent energy between meals. It's similar to amylopectin, but it's more highly branched. So the glucose units in glycogen are joined by the 1,4 glycosidic bonds with branches attached by 1,6 that occur every 10 to 15 glucose units. So the branch alpha 1,6 glycosidic bond is present every 10 to 15 glucose units. And again, glycogen is the polymer of glucose stored in the muscles and the liver and gives energy between meals. It's a branched polysaccharide. It is similar to amylopectin in that way. Cellulose is a major structure unit of wood, is a polysaccharide of glucose units in unbranched chains with 1,4 unit glycosidic bond, cannot form hydrogen bonds with water, thus is insoluble. It gives the rigid structure in wood and fiber, is more resistant to hydrolysis. It does not break down that easily. Cannot be digested by humans because humans cannot break down the 1,4 glycosidic bond, the beta 1,4 bond, and it's usually animals can do that. So cellulose, an example is cotton or the bark that we were discussing, the bark of the tree. Again, the beta 1,4 glycosidic bond, this is the beta bond above the plane, OH. So these are two examples of cellulose, the polymer or polysaccharide. Identify the polysaccharide and type of glycosidic bond in each of the following. So this is a cellulose that we were talking, and this is amylose, amylopectin. So the polysaccharide in cellulose, beta 1,4 glycosidic bond is the bond. Identify the polysaccharide. So bark, cotton, the polysaccharide is cellulose. Amylose is alpha 1,4 glycosidic bond. Amylopectin, alpha 1,4 and alpha 1,6. You can see the beta bond is something that we cannot digest. Only the animals can do it. And these two are alpha bonds present in the starches that potatoes, etc. So this is a concept map. The carbohydrates, all that we discussed, is a map that you will find in your book, and this will be a good way of keeping everything in one place. And review, it's helpful for review, so please look at this map, and I think this is what where we started with. So